Alright, for lesson 2 we're going to do some multiplication of monomials to monomials using exponent laws, and then start to practice in the last few examples polynomials. And I'm going to look at all the different types, so I'm going to end up working through about 8 different examples with you here. The first two are just going to be straightforward monomial times monomial, but it's going to include some of the exponent laws. So example number 1, we're going to multiply 4a squared b times 2a b squared times ab squared to the power 2. Now the first thing you do is, if you, again, just like in lesson 1 where we expanded out brackets, we are also going to do that in this lesson as well, which means if you have some power of a power, like I do on the ab squared term, expand that out first before you start to simplify. So the first thing I'm going to do is write this as 4a squared b times 2ab squared, and then I can write it as ab squared times ab squared, or I can realize that power of a power means a to the power 1 to the power 2 should give me a squared. B squared to the power 2 should give me b to the power 4. Power of a power means to multiply exponents. Now that I don't have any more power of a power, what I'm going to do is take care of the coefficient first. I have a 4 times 2 times 1 to give me 8. Now look at the a's. A squared times a squared. Well, even if you want to write these out, this is what it looks like. It's a to the power 2. Since they're same bases, you are going to add exponent. So it'll be 2 plus 1 plus 2. And then you have b to the power 1 times b squared times b to the 4th. So I'm showing you an in-between step. I probably won't do this step on the next example. All that you need to remember is that when you multiply same bases, you will add exponents. So this should simplify to being 8, a to the 5, b to the 7. So power of a power in this case, where you multiply exponents. Multiplying powers, which was the second case, is where you add exponents. So the way that I always remember it, one base to more than one exponent, multiply exponents. Multiplying same bases, add exponents. Let's look at another example of a couple monomials being multiplied. Example number 2. We'll go with 2x squared y to the power 2 times 3x to the power 0 times 2x to the negative 2 y to the negative 2 to the power negative 3. This one's a little bit more complicated. You can see we've got quite a few power of a powers. We also have an exponent of 0, and that's the one I always tend to take care of first, because that really simplifies my expressions. Anything to the power of 0 is 1, so 3x to the power 0 I'm just going to replace with the number 1. Do power of a power to the first term. That's going to be 2 to the power 2, x to the power 4, y to the power 2. The second term is just 1, so I'm not even going to write that. And the last term is going to be 2 to the power negative 3, x to the power positive 6, y to the positive 6. I'd work out the coefficients. 2 squared would be 4. 2 to the negative 3, well, a negative exponent really means to write the reciprocal. So 2 to the negative 3 would really mean 1 over 2 cubed. Well, 2 cubed is 8. So there's where I take care of my coefficients. 2 squared is 4. Anytime you have a negative exponent, that means you write the reciprocal, or what a lot of people remember, if it's a negative exponent on the top, it moves to the bottom and becomes positive. If it's a negative exponent on the bottom, it moves to the top and becomes positive. So negative exponent rule just means to write the reciprocal, and 2 cubed is 2 times 2 times 2, which is 8. We get x to the 4 times x to the 6. When you add those, you get x to the 10. Y squared times y to the 6 gives you y to the 8. Simplify this one more step, because 4 eighths can really be reduced to 1/2 x to the 10 y to the 8. So this one involved a couple rules. Actually, it involved 4 rules. Power of a power, power of 0, negative exponent law, and multiplying powers. Pretty good little example with a couple monomials. Let's do some expanding of binomials for the rest of our examples. Example number 3. You still use your exponent laws for this, but the binomials don't tend to get as complicated. You just have more multiplication to do. I'm going to take a pretty straightforward one. 2x minus 4. And I'm going to multiply it by x plus 6. So it's a binomial times a binomial. We tend to use the FOIL method, meaning first, outer, inner, last is how we expand this. Or a lot of people just look at it as distributive law. Distribute the 2x to the other binomial, distribute the negative 4 to the other binomial. That's really what you're doing. So you get 2x times x to give you 2x squared. 2x times 6 will give you 12x. Negative 4 times x, negative 4x. Negative 4 times 6, minus 24. Look to collect like terms. Usually your inner terms are like, so we'll get 2x squared, 12 minus 4 to give us plus 8x, minus 24. Quick little expansion there, using FOIL. So if you have a couple binomials, you can always use FOIL. In our next example, we're going to look at one of the special multiplications. And again, with example 4, if you want to just FOIL this out, you will never get this wrong, but there is going to be ways of going with shortcuts. 2a minus 3 squared, there is a shortcut to expanding this. Rather than just writing 2a minus 3 times 2a minus 3 and using FOIL, since they're identical binomials, the shortcut is to square the first term, meaning 2a times 2a will give you 4a squared. You can get the middle term by multiplying those two numbers together and then doubling it after. So 2a times negative 3 gives you negative 6a times 2 to give you minus 12a. And the last term is going to be the last term of the binomial squared. Negative 3 times negative 3 to give you positive 9. And that's the quick way of expanding these out. You don't have to FOIL. You don't have to collect like terms. It's all done in one shortcut method. So it's square the first, multiply the two terms together and double it for the middle, square the last. Next example. Example number 5. We have a binomial 3m plus 2 times a trinomial 2m squared plus 3m minus 4. Now you might be thinking FOIL, but you can't really FOIL because FOIL's only for a couple pairs of binomials. But what you're going to do is distribute the 3m to every single term, the 2 to every single term. By the way, if you wanted to distribute the larger polynomial into the smaller, you still would end up with the same answer. It's just a little bit different of a way of doing it. We tend to always take the smaller polynomial and expand it into the larger, but you would get the same result if you did the other way around as well. So I'm going to multiply all three terms by 3m. 3m times 2m squared will give us 3m cubed. 3m times 3m to give us 9m squared. 3m times negative 4 to give us minus 12m. Now distribute the positive 2 to give us positive 4m squared. 2 times 3m to give us plus 6m. 2 times negative 4 to give us minus 8. Now you have to do a little bit of searching to collect like terms. There's only one cubed term, so we get 3m cubed. I have 9m squared plus 4m squared to give me plus 13m squared. Minus 12m plus 6m gives me minus 6m minus 8. So in this case, I ended up with a 4-term polynomial after my expansion. Expand out the brackets, collect like terms. Whether it's a binomial, trinomial, perfect square trinomial, different squares trinomial, you always use the same process. Alright, let's look at a couple harder examples to wrap this up. Example number 6. We're going to do a binomial 3x minus 2 into a polynomial that's got brackets within brackets. So 3 plus 2 times 2x plus 4 times x minus 1. So again, just like we did in the last lesson, we're going to expand out our innermost brackets first, then do our multiplication. And we'll simplify as we go. I'm going to FOIL this first set of binomials. First of all, FOIL. First, outer, inner, last. So I'll go 3x minus 2, keep my big brackets, 3 plus 2 times this product. 2x times x will give me 2x squared. 2x times negative 1 gives me minus 2x. 4 times x, 4x. 4 times negative 1, minus 4. Now some people like to collect at this stage and then multiply. That's one of the things I like to do. I always like to simplify as I go if I can. So I'm just going to write the simplified version. 3x minus 2 bracket 3 plus 2, and I've got to distribute into that simplified polynomial. Collect like terms. I get 2x squared plus 2x minus 4. And now I got to do distributive law again. Now I distribute the 2 through that trinomial. I get 3x minus 2 bracket 3 plus, and then I end up with 4x squared plus 4x minus 8. Collect like terms one more time inside the big square brackets, and then we could do our last step of multiplication. 3x minus 2. I'm going to write this in proper order as well. I'm going to write it as 4x squared plus 4x. 3 minus 8 will give me minus 5. And then we're down to a type of polynomial we've already dealt with in our last example, a binomial into a trinomial. So we're going to go 3x times everything in the trinomial, negative 2 times everything in the trinomial, and collect like terms one more time. So 3x times 4x squared will give us 12x cubed. 3x times 4x to give us 12x squared. 3x times negative 5 will give us negative 15x. Now take the negative 2 and distribute. Negative 2 times 4x squared gives us negative 8x squared. Negative 2 times 4x will give us negative 8x. And negative 2 times a negative 5 plus 10. It's really easy to forget a sign or to forget a power, so you got to be real careful. Collect like terms. 12x cubed. 12x squared minus 8x squared gives us 4x squared. Negative 15 and negative 8 to give us negative 23x plus 10. Do a quick check when you finish completing these, because these are usually worth a couple marks if it was a written response, which you don't get on an online environment, but you would have 4 choices after working this through, and then all of them would have very similar coefficients, maybe opposite signs, just in case you were making a mistake on a sign somewhere along the way. So again, expand from the innermost bracket out, collect like terms as you go, keep expanding, keep collecting until you can't collect like terms anymore. Example 7, we'll work with a couple of those special ones again. We're going to go with 3y minus 1 squared, and we're going to subtract 4y subtract 5, 4y plus 5. So these are 2 of our special products. The 3y minus 1 will end up being a perfect square trinomial, and the 4y minus 5, 4y plus 5 is a difference of squares. So there are shortcuts for these, which I'm going to use. When you have the perfect square, you square the first. So 3y times 3y gives me 9y squared. Multiply the 2 terms together and double it. So 3y times negative 1 gives you negative 3y times 2, give you negative 6y, and then square the last. Negative 1 times negative 1 is positive 1. And we're going to subtract, and notice I'm going to put brackets around this. This is a difference of squares. So the nice thing with difference of squares is all you need to do is multiply the first terms together, multiply the last terms together, because your middle terms cancel. So it really only becomes 4y times 4y to give you 16y squared. 5 times 5 gives you negative 25. You don't have to worry about the middle terms in there. They actually do cancel right off the bat. Difference of squares is a simpler one. You don't even worry about the you'll always end up with just a binomial after. Now distribute the negative 1 to get 9y squared minus 6y plus 1 minus 16y squared plus 25. And now collect like terms. 9y squared minus 16y squared should give me negative 7y squared minus 6y. 1 plus 25 to give you 26. Simplifies to a trinomial. There's our two special cases, perfect square and difference of squares, to simplify our expansion. And the last example we'll do is a cubic. So example number 8. And a cubic really is just kind of a combination of two of the ones we've already done. So we'll look at 2a minus 5 cubed. Now the first thing we can do is turn this into something we've already worked with and write this as 2a minus 5 times 2a minus 5 squared. We have a shortcut way of expanding out a perfect square, and then we'll just distribute that binomial into it. So I'm going to write this as 2a minus 5, use my shortcut, square the first, 2a times 2a to give me 4a squared, multiply them together and double it, so that'll give you negative 10a times 2, give you minus 20a, square the last, negative 5 squared, give you plus 25. And now we're back to a problem we have done already a few minutes ago. Now we'll distribute 2a into all three terms, distribute negative 5 into all three terms, and then collect. 2a times 4a squared, 8a cubed. 2a times negative 20a minus 40a squared. 2a times 25 plus 50a. Negative 5 times 4a squared minus 20a squared. Negative 5 times negative 20a will give us plus 100a. Negative 5 times 25 minus 125. Collect like terms. There's only 1a cubed, so 8a cubed. Minus 40a squared minus 20a squared, negative 60a squared. 50a plus 100a plus 150a minus 125. So with those 8 examples, I did a couple monomials together. I dealt with every type of binomial expansion, plus a brackets within brackets question, plus a binomial times a trinomial, the perfect squares, the difference of squares, and even a cubic.